Good evening, everybody, and welcome to this new session. Tonight, we want to discuss a new topic about the robotic operating system. What is ROS in general, and how to install ROS in our computer. Okay. The ROS, or the robotic operating system, is similar in architecture or in working principle to the normal operating system, because it organizes the communication and the sharing of resources between multiple applications. And these applications in ROS are called as nodes. For example, here in Windows, okay. For example, in Windows you may have a Word, a PowerPoint, Mozilla Firefox, okay, Outlook as a mailer, PDF, Acrobat PDF, also ABP Robotic Studio. All of these are applications. Okay. In ROS, we call these applications as packages. Each package may contain more than one node. These nodes will communicate with each other. Okay. The node can act as a publisher, subscriber, client, server. Okay, so the main function of the ROS is to manage the communication between these nodes, because the normal operating system like Windows and Linux, the main purpose of these operating systems is to manage the resources and how to share the resources of the computer among those applications. And these resources are RAM, the CPU, for example, and so on. Okay. In control systems, we can utilize these nodes to play multiple rules. For example, in control system, we have a sensors, we have a controller, we have actuators. So the sensors usually sends regular messages or regular information to the controller. The controller, based on this information, will make some processing, some computation with its equations or algorithms, and then will send the computed or controlled output regularly to the actuators. Okay, of course we can utilize one node to act as a publisher. The controller has to subscribe to these messages, and the controller also can act as a publisher and subscriber. So the node can act as a publisher, subscriber, or both publisher and subscriber. Okay, and the actuator and the controller will also publish its message to the actuators. Also, the node can act as a client server, because for example, I need to adjust the reference command of the reference input. For example, if I want to control temperature, I want to set this parameter to be, for example, 30 degree. So I need another architecture, which are client server. Okay. One of the secrets of the ROS is based on DDS, data distributed services. Each published message will be published to all devices in the local area networks. So if I installed ROS in another operating system, and if both nodes subscribe to the same topic, we have a topic, okay, so the subscriber can listen the publisher. Each subscriber subscribe to the same node of the publisher. They can listen to the publisher messages. Okay. So this is the default situation, except or unless if we change the node domain ID. Okay, if we make a different node domain ID, so the subscriber could not listen to the publisher. Okay. So without further ado, let's take a look at the procedures to install the ROS. Before that, as we demonstrated, we have MATLAB and Peter Korg MATLAB Robotics Toolbox. Okay, we have MATLAB Robotics Toolbox. So just we can move to this side, download this toolbox, and just double click on it or open file from MATLAB to install this MATLAB Robotics Toolbox. Okay. Now, in order to install ROS, we have two options. Either we can install the ROS on different Linux. The ROS, the robotics operating system, is full supported in Ubuntu. Okay, so we can make a double boot. Just go download your version or your distribution. You can follow the instructions here. Okay, you can use a bootloader like Rufus, okay, or this one, which is used in this tutorial. Okay, so this is the preferred option, okay, because when we make a simulation with Gazebo, visualizing, if we want to make a visualization to our simulation with Gazebo and Arvis, these programs consumes a lot of CPU and GPU resources, so it is preferred to double boot. It is better, but if you have a limited resources, or you could not install Ubuntu in separate partition, so you can use Windows Linux subsystem. There are other options like virtual machine, other virtual machine like VirtualBox, okay, vMore, but I don't recommend it because it has some limitations in GPU to deal with the graphical user interface and utilize. So you may face some difficulties and problems if you want to use gazebo or arfis. So this is one of the alternative option to use Windows Linux subsystem GUI WLSG, which is based on WLS2. Okay, so these are some important links and instructions to install WLS. Okay, so I will demonstrate you how you could install the ROS, the Windows Linux subsystem. Okay, so let us here you can see that I have here I have installed Linux, yeah, Ubuntu. Okay, and here I have installed also the ROS2. Also, I have installed yeah, this Visual Studio Code. Yeah, and this Visual Studio Code is connected remotely with WSL Ubuntu. So also here I can ROS2. Okay, I can open multiple terminal. Okay. So to check that if my installation is if my ROS is installed correctly, just I can run two nodes Docker. You can see here this Docker will publish this message. Okay, hello world 12989 and so on. And here I can run the listener. Okay, here you can run listener. To listen now to listen to nodes number 35, 36, the current message. Okay, so now my ROS is installed correctly, my Ubuntu is installed correctly. Okay, so I can stop by Control C. So now the question, how we can install the ROS professionally and correctly in Windows Linux subsystem, Windows Linux subsystem. So as we said before, okay, we need to follow the instructions in this manual here. So this here for Windows Linux subsystem. First of all, we need to enable the Windows subsystem for Linux. Okay, and before that, we have to check our build, our current version, because in order to operate WSL2, there is some requirements. Okay, so first of all, we need to check. We have to run we want to run this command, Windows version. So our build have to be greater than to be 1.18.36.2. Okay, or later. Now my build here. I am installing Windows 10 with this build, so this version could support the ROS, the Windows Linux subsystem. Okay, please read this instruction manual also for Windows 11. You have to check your build also. After that, you can enable the Windows Linux subsystem either from PowerShell, okay, or just I'm typing here features. I will open Windows features. Windows feature. Sorry for that. Turn Windows features on or off. Okay. So just we can turn Windows features on or off. And searching for, now we need to search for the virtual machine features and Windows subsystem and Windows Linux subsystem. Okay, so we need to check virtual machine platform and Windows subsystem for Linux and hit this button. Okay, and after that you have to reload, or you have to restart your computer. After that, if your Windows Linux subsystem is version 1, you have to update, make some update with this command. So just open PowerShell. The PowerShell is a new version of command terminal. Okay, so we need to open PowerShell. So just we will make fewer steps after opening PowerShell. The first step, okay, we need to make some steps with Windows PowerShells. The first step is to make updates, and after that we have to set the version to be 0. Okay, we want to make update. After that, some of the commands we need to make update firstly, then we need to set the version to be 2, and after that you can install Ubuntu. But please do notice here that this is now the default version of Ubuntu is Ubuntu 22.04. So this may be changed later on. Currently I want to install the ROS2 Humble, and ROS2 Humble is supported with Ubuntu 22.04. If I want to know the name of distributions, okay, for example Ubuntu, I can type for example this name instead of just Ubuntu. Please use these names. For example, if you want to install this version, this version. After that, the ROS2 will be the Ubuntu will be installed. Okay, will be installed in your computer. So now we will make some check. Okay. Also, you can install the Ubuntu from store, from the Microsoft Store. Just type here store, Microsoft Store. Okay, but I recommend you to use the command line. Also, it is preferred to install this beautiful multi-tab command line, which is which is a Windows terminal. Okay, you can install it also by searching for store. Just by typing here store and open Microsoft Store and search for Windows terminal. So after that you can obtain this beautiful terminal. Okay. In order to install ROS, you have to go to these links here. Okay. docs.ros.org and choose Debian package. It is recommended because it is, for example, Gazebo is not fully supported in Windows. And just follow these instructions, copy and paste these steps. Also, you can search in the YouTube for some channels that follow these steps, these instructions step by step. And finally, just to test your ROS is running, just you have to type ROS2 run demo node cpp talker and listener. Okay. Type of this. Okay, now also you can install classic Gazebo. By the way, if here you want to install a new version of Gazebo, we have two versions of Gazebo. The old one and preferred for most of the developers, the classic Gazebo. Also, there is a Gazebo Sim, the new version. Okay, if you want to install Gazebo Sim with ROS Humble desktop, because the current installation just to install ROS and RVs demos tutorials, just you have to write here -full. Okay, when you choose these options, if you want ROS version without graphical user interface and so on, yes, you can choose these options. Okay, so now I installed Gazebo Classic. Just write these instructions. Install ROS instead of Foxy, write Humble, and after that you can install this tool, geometry tool. Okay, tool. Then you can, for example, we can run this world with appropriate plugin. Okay. So the gazebo is a separate project for simulation, but there are some plugins. A plugins is a code that can be executed inside other programs. There is a plugin that enable gazebo to act, to enable nodes in gazebo. Okay, just we can run this command, but instead of Foxy, sorry for that. Instead of Foxy, I want to type here humble and share. It may take some time. Just be patient for that. Okay, now if you faced some problems while opening the gazebo, just close it, kill the process, kill the process with Control C, and then reopen it again. So here we can see, here we have gazebo. After that, we can run this command to move the gazebo linearly. Okay. For example, here we want to open another terminal. Okay. Move the gazebo here. You can see now the graphical user interface of Windows of Ubuntu. These programs are working on Ubuntu, not on Windows. Okay. So we can write this program, for example, in order to move the gazebo. Now it moves. Okay. If I want to, for example, if I make the speed -1, the robot will move backwards. Okay. To the same point. You can see here that the robot now, so I can put the speed to be 0. To stop the movement of the robot and so on. Okay, so now I am publishing the velocity to the robot in the gazebo. Also, I can use the teleop operation. Okay. I can use telemetry operation to use a keyboard to control this robot. Okay. So just I can run this command here. Okay. To use the keyboard and make some mapping. Now just if I press I, for example, press I here, the robot will move forward. K, the robot will stop. K, the robot will stop. I, the robot will move forward. K, will stop. Okay. If I want to move the robot right, press for example L, K to stop. So here we can see this is considered as a differential drive robot. Okay, is under actuated robot. We have two wheels. There is no wheel steering. Just we have two wheels. In order to move the robot forward, we have to just rotate the two wheels with the same speed in the forward direction. If I want to make a rotation to the right, I have to move some of the wheel with high speed than the other, okay, and so on. So here I have two joints, and we are gonna to move this robot in 3 dimensions. So this is always under actuated because the degrees of freedom, we have 3 degrees of freedom, or we have and we have just 2 joints. Okay. Similarly, I can open a new gazebo, which is ignition. Okay, I can close this by Control C, and this also by Control C. I can move to this link here. Yeah. To run ignition. Okay, just you have to follow the instructions here. Just we will use this ignition. For example, okay, the ignition, and this will open the gazebo ignition. Oh, here we can see the gazebo ignition. Okay, after that, you can see the topic list. You have to install this bridge. I installed it. I have installed this bridge previously. We have to, in order to, I can run this command. Okay, but I want to use a tele-op. Also, you can install the tele-op keyboard. I want to make for that I have to make some bridge. Okay, we have to make some bridge here, and you can see the ignition. Okay, we need to make some bridge now. Finally, we can run this code. By the way, this command is required when we open a new terminal to source the ROS, to make the ROS instructions available to the command line. Okay, but editing, just you have to edit .rc, I think so. Edit.rc, if I spell it correctly. Okay, yeah, it's correctly. And just put this file will be on robot or the terminal, a new terminal will open. Each time you open a terminal, this file will be executed, so that you have to write source humble setup here, and we don't need to it. Okay, but here. Now we can run the teleop. Okay, now we can run the teleop. Sorry if there's some problems with the voice, because now the CPU, there is a lot of utilization and for the CPU resources, so the mixer, the audio mixer may face some problems. Okay, so don't worry about that. Now we can move this robot forwards by just typing I, stop it by K. Okay, stopping it just by K. Right by L, and so on. Okay, okay, to stop this robot. Now, if we want to visualize, to use ROS to visualize the LiDAR scan, for example, we just want to open new terminal. We want to open new terminal and run this command to make some switching for laser scan for these messages. Okay. After that, sorry for that. After that, we can run another terminal and just ROS2. Open ROS2. Yes, we will open the ROS2. As we said before, the ROS and gazebo ignition are running above Ubuntu. It is not open inside Windows. Okay. So here just we can see our LiDAR, and we can add, if you follow the instructions here, we can add by topic the laser scan. So the ROS is used to visualization. We can add by topic, for example, laser scan. So the resources of ROS and gazebo is very important. Okay, it is the high-end resources. Okay, and any channels or any other sources also takes their information from here. Okay, we have to type here in the fixed frame this information here: vehicle blue, LiDAR link, GPU LiDAR. So let me pause. Okay, so now after typing here, we can see the LiDAR output. Okay, So now I hope you find this video very interesting and very useful. Thank you very much for watching and your time.